up to today. It's a DLAB number 11. Up to this time, I still have Marcelo. It's a number 11. It fell. And holding Adam is number 11. Still fell. I got no update yet. And Mr. Nicholas, number 11. Okay, and now number 12. I have a 2. DLAB number 12 is a 1 from Mr. Luyuk. It's a fail. And I will show this one, this program later. Now, Mr. Kemsut. I have a DLAB number 12. It's also failed. And now I'm going to run the DLAB number 12 of Kemsuk. Okay, let's see. Let's wait a minute. This one is a program I was corrected. Okay, and I want to show the original. It's Kemsuk. It's a update today. So that is a fail. The one I just run is a part because I corrected. Yeah, this one is a program number head number 1, 2, 3, 4, 5. This is number 4. This is number 5. The reason is it's not so fail because in the read memory here, Mr. Kemsuk is not perform validate. Let me show you. So that's why it's not showing fail. So it's right here. It have just enable and then read, but it's not reading and not verified. Okay, so what I have to do is I have to show this one, this test is a fail. I have to do this. I will add the test validate after read memory, or let's put it in the read memory inside of the function. Okay, so we will rebuild and we'll run this one again. It will show the test failed. That is a mistake. Testing without verify. See, because the test was run, the original it's a upload. It's in the reading. In the reading right here, it just says it's a read function, read memory, but not verified, not at reading from the port C and not it verified at pass or fail. So when I adding in the test validate here, it will show the test fail. And now we have to go and look for it why the test failed. Okay, Mr. Kemsuk, are you here?
I think he's here. He's just maybe a mic. He is in the chat room saying yes.
Huh?
He typed in the chat room that he is here.
Okay. So now when I add the test, it's a validate in the read memory. So that memory test is a fail. The first four tests, 1, 2, 3, 4 is pass. But when the 5 and 6, you are testing the memory, it's fail because you are read memory, but do not verify. I add the verify that reading data, and now it failed. We have to find out it where, but actually I already corrected, and then I send you an email as to how to correct and update that again, okay? But let's check and see what it fell in here. I already make a note in here that said it's you forget write memory and read memory where it needs to be correct, okay? So you forget okay, here we are.
Should be 0x00.
Yeah, it's right here. You have to write it's 0. Port B is 0. Okay. And then it's in the that is in the U for latch and usage lock. Usage lock is okay. You read memory, write memory, and here it's the write memory. The write memory have a mistake in here. This one is the right data. Port D is 1.6. It's not 1.5. And the read memory, I already add the validate in there. So this one is right here. So that is all I think. Oh, let's go back into see what the test number 6 look like. Yeah, I remember it. I fixed it. Oh, okay. This one is you write the memory right here. You can write only one time. Memory for the A data is write memory address A that 55. Write memory address 55 is for AA. So now you are test number 6. You verify AA. So I have to comment out this line because you write address AA again. Okay. So I think that is all to correct your lab at the first test, first 6 tests. And that's all what we need you to do. And after today, and you learn about ADC and the rest of the part of the schematic, you will have to do all of them end to end. Now let's run it again.
I think there's a fail, isn't it?
It failed test number 4. Let's say. Oh, okay.
There's one fail.
Oh. It failed number 4, number 5 before it failed number 6. Okay, just a memory test, it's a fail because you are not verified when you read them. Okay, here we run it again with the correction. Okay. Okay, so test number 4, number 5, and number 6 is a pass. That means it's your function. It's a section in the program is correct. So you run the ADC data or you run the complete memory test should be okay. Okay, so the correction here, I already sent you an email just about half an hour ago. So you can, I will with the attach this file, you can just look into it and update your program and send it back to me. Okay. And now another student have DLAB number 12, Mr. Luyuk. Let me put this program up here and see.
Did you get the one I sent over today?
Oh, Luke?
Yeah.
Michael?
Yeah, Michael, yeah. I sent one to you and I also upload on the website.
I know. Let's check the date in here because I know I got this one. It's not from a download but from email.
Right. I got the other one.
Yeah.
I upload one.
So the email is the first one is August 1st. This one is original, I believe.
Mm-hmm.
Okay, so now let's see how the only 6 tests.
Yeah, I only did 6.
Okay, yes, I understand. We just asked you to do only 6 tests. Okay, now let's build it and then see. We can run your program. Yeah, and I believe that this one also fell, but I don't remember where it fell.
Yeah, it was the expected data. I typed it wrong.
Okay, we'll see. And then I also send you an correction by
Right.
email.
Yes, I
Okay, you got
received.
that. But
Yeah,
you
I got that,
haven't.
and then I updated it and then added another test as well. Yeah, so that's the one I sent over.
Okay, so this one is a memory test. It fell the old one.
Yeah.
Okay, so now just forget the old one, and then let me look and see if I have in my email, and you have it.
Email or the class one, either one. I uploaded to.
Yeah. Oh, I can see your upload, right? Okay, let's check the email. Michael, look.
Yeah, that's the one.
Oh, this one, the new one here.
Yeah.
Today, 349. Okay, so let's get this one. I hope this one should be okay.
I hope so too.
If you do it, what I already let you know, it you need, and then it should be past the 6 test.
I think I did everything you put down.
Okay, now Michael. Okay, this one is the new one today. So we build it and we run see. Okay, hopefully it should be okay. Just a 6 tests. Okay, 1, 2, 3, 4, 5, 6. The 5 and 6 is the testing the memory data, just the 2 locations. Oh, so now you are making the same mistake again. So you are not verify when you do a read memory. Let me check again. See?
Yeah, but then I did put down test validate afterward. At least on one, I forgot to do on the other.
Validate in here. I have it here. Put it in.
I did put it there, but I guess I didn't put it on the one before, maybe.
Okay, so here we go. So at least you are the first two who have it's a DLAB12. It's complete and then able to run. That's very good. Good work. So number 5 and number 6 pass and should be okay now.
Number 7.
So this should be ADC test.
Right. Yeah.
So if you pass number 5 and number 6, and that means the rest of the ADC and then the whole memory location will pass. Okay.
Okay.
But the other one is with the hardware of the ADC. That's a different story because they adding more hardware in there.
Yeah, there's the next one. They asked for the manual DAC test.
Yeah, that one. That is the one you are learning it today.
Yeah,
and you will put in your software. Okay, so the ADC also passed. So very good, Michael.
All right,
so
thank you.
Your lab up to this time it's okay with the test validate in the read memory. When you update again.
Yeah, I corrected on my side. Thank you.
Okay, thank you. So that is the II DLAB number 12. I'd like to show you guys today's. Okay, any question about DLAB number 11 and number 12? Okay, so now back to you, Mr. Pham. I stop there here.
So we don't have any more. We don't have any new more.
No. That's all what I have up to this time for the hardware. DLAB, but digital lab, but verify with the hardware. Okay. No more new of the 10, DLAB 10, DLAB 11, and DLAB 12. I have only 2.
Okay, so we get up from lab number 1 to now will be the lab number 12. I don't know how you guys do it. You don't know how to write the test program to test the circuitry. Anything you need help, then you need to bring it up. I think we try to get the software done. Only 3 more weeks. We start in the lab. That means at that time, you have to build it and you have to verify with your software. If you cannot write a program, no way you can get the lab done. So anything, any idea, what can we do?
Hey, Mr. Pham, I got a question.
Yeah, go ahead.
On DLAB 12, because I'm starting it on the Excel that dated on the web July the 27th. That's up to date, correct?
Yeah, I think that's a new one.
Okay, so July 27, 2021 Excel that's on the web for DLAB 12, that's up to date and correct.
Correct. Let me share. You're talking about Excel, right?
Right, the Excel. I just want to make sure, because I thought you had one up there and then you took it down and put it back or something like that.
This is the Excel uploaded, right?
Right. So this is the one we should be working on, correct?
Correct.
And it's any updates that's been made recently is on here.
No. Nothing wrong with the schematic.
Okay, so it's okay. So you said it's okay, right, Mr. Pham?
Yes, sir.
Then I'll work on this.
This is the lab almost the same. In the past, lab 11, memory, and another one before. I think that's number 9. Same way. Only thing different, we added this circuitry here. That means we're adding the digital to analog converter. So they converting from binary here to the analog voltage right here. Then that analog will be going to this right at that one here. Okay. So this will be going to voltage follower. And you get the analog coming in. This IC will be converting A to D converter. That means you get analog input that convert to binary. And that go to the buffer, and they will be go to the U2 so they can read it and verify it. I will be go through this lab again. When you're looking into the lab, you must be recognize the part, the IC in the lab and how it is working. The thing is, for the digital course, sometimes very easy if you know what to do. Not too much theory. Okay? Everything I already given to you and try to explain to you how it's working. The thing is, you only deal with a binary, either 0 or 1, 0 volt or 5 volt. Okay? So, on this one, I go over again. If you get confusing, anything not quite understanding, then go ahead and get a question. The first IC here is 1. You already know U1. That will be serial data converting into parallel data, 8-bit parallel data. And you don't worry about the serial. The thing that we already given you, the function will do it for you. Okay, you call that function, you send it data 0855, then they will be go into U1. And 8-bit, they need the one that clock positive going. So they will be shipped into the parallel here. Only thing is when you send the data 0855, and you check the output here, you can get 0101. Yeah, okay. 01, 01, 01, 01. That means 55. So that's a very simple job. Call the function and tell that function you want data, whatever data you want. 0855, 08KA, 08F5, whatever data they converted.
Hey, Mr. Pham, just for the sake of understanding and review. So basically, the data comes in through PA1 and goes to pin 1 and 2, which is A and B. And then, but when it comes out 1 bit at a time until you get all 8 bits. And for each bit has got to be moved over by a clock.
Right.
Can you just say that better than I did? I don't, maybe you can say it better than what I just said.
Okay, you need 1 clock for 1 bit going.
So, but the information comes out of PA1, correct?
Yeah, then the data you want.
Right.
55, AA, any data, 8-bit, but they be serial.
Okay, so it comes out of there 1 bit at a time,
Exactly.
and then it goes into pin 1 and 2 or A and B,
Yeah, they go to A and B.
and then what happens?
They will be transfer the bit from AB to output here. If you get a 1 here, you apply the clock, then output will be 1.
Mhm.
If you get next will be 0, you apply the clock, then 1 will be shipped down and 0 will be moving in.
Mhm.
That's the way the IC working.
And it keeps doing that until it gets to either 55 or AA.
Yeah, they
And then-
keep doing until you get 8-bit.
Right, and then once you get those 8 bits, those 8 bits move over to U3, is that correct?
Yeah, they connect to U3.
Okay,
Okay, now, normally when you're doing the lab and the test fail, okay, at the test number 1 failing. So you need to troubleshoot it. First thing you have to make sure if you get the data 55, you have to make your idea have to be okay 1 0 1 0 1 0 1 0. Okay, if you get that data, that means you want good. So if you're not, what can we do?
you have to go back and see if the clock was working, or if
Yeah,
what-
if you want to see in here, basically you cannot see the serial. Okay,
Mhm.
so that's why we have to using software to let that sending over. Okay, let's see. I get the software here. This is a function you need. Right here. Void serial. Okay. And
Right.
this is you don't care what they doing. The thing that we have to working on in order converting serial to parallel. Okay. Now it failed. Okay. Then in your program, test number 1, you see, test number 1, you call this function for 55. Okay, so if you want to troubleshoot it, you have to let it run. Okay, you can say for loop, right? For. Okay, let's see. Come on. Okay, you understand that? What that means? That means I want to run forever. Normally, you can say for j from whatever to whatever number. But when you say semicolon, they will be run forever. Then you put the open the breast. Okay. Now, what you want to do? You can put the glow here. So when you run the program, okay, they will keep run over and over. Okay, now you can see, I can compile and run it for you. See that? They keep run. Okay. So
You're
I will
checking the clock. You're checking the clock right there.
take everything.
Oh,
That
okay.
means that will be telling you what? That means telling you they're telling you the data will be sent here. You can looking on the scope. You can see look like a square wave. 01 with 01, keep going. Okay. And if you look at the clock here, and you can see the clock keep going up, keep going. So guarantee you get the clock. Guarantee you get the serial data coming. Without it, adding that software, you cannot check it.
Okay, Mr. Pham, in your scenario right here, you said the 5-5, you didn't have the 5-5 on the output. So you did what you just did. You checked the clock and you checked PA1, and that was okay. So then you also got to make sure pin 9 is 5 volts, correct?
Exactly. Okay, now, if you already get the serial coming in good,
Right,
clock is good.
right.
Now, if you're looking at the output here, you can get a keep going, square wave going on each one. Okay, they keep run.
Okay,
If you still see nothing in here, and now what you need, you have to check pin number 9. Okay, they must be connected to 5 volt. Okay,
because you don't want it to clear.
right. Whatever on the schematic show you, take what they want on the schematic. They connect to VCC. If you measure pin 9, you suppose to get what?
5 volts.
5 volt.
Okay, so let's say pin 1 and 2 was okay, pin 8 was okay, pin 9 was okay. So then at that point you change the chip, right?
Not yet.
Not yet?
The first one, then you need to make sure pin 14, 5 volt, pin 7,
Ground.
ground. The thing is they not show up in the schematic,
Right.
okay? And the IC need the power and ground.
Right.
If you check everything like I said, then now you're asking for another new IC.
Another 74-164.
Exactly.
Okay, that's what I want to know, the steps, how you check it out and everything.
If you know how to do what to do, when you build it, you run the fail, and you know how to do. Get it. exciting for you to fix the problem. So that is the first part. Okay. On the basic test, what they doing on the first test, they sending 5 here. They go to U3. U3 is 541. Just a buffer. Whatever here will be going to output U3. If pin 1 and 19 is 0. That I see, that's a very simple. If you get a 1 in pin 2, then you get a 1 on pin 18. Okay, if it's not, that means one logic input not go to the output. What you have to do, take U3 pin 1 and pin 19. Make sure they be 0. If they not going down here, they go to U number 8. Then you have to make sure pin 4 have to be 0. Okay? And pin 4 is not 0. Then that you must be check pin U8, pin 2, pin 3 supposed to be 0, 0. And pin 1 must be round. If pin 2, 0, pin 3, 0, pin 3, 0, and pin number 4 not 0, then you have to do in the lab, you can remove the wire here. Take pin 4. If you still not get 0, then the IC. You see that the concept testing,
And Mr. Pham,
troubleshooting, you have to prove the input is right, but the output not right.
on that, what you just said there, okay, pin 2 and 3 are 0, so pin 4 should be 0. So you pull the wire, and when you pull the wire, you put your test lead actually on pin 4 on the IC itself, correct?
Yeah, when I think maybe did I see U3 can cause the problem. So that's why I must be remove the wire here and take the U4. Guarantee nothing connect to pin number 4.
You check actually on the pin itself, correct?
Exactly. When you measure, you have to measure on the pin of the IC, not the wire.
Mhm.
And whatever, I did it in my work in the company.
Now suppose pin 4 on the IC is 0. Then what do you do? Because you pulled the wire.
Now, if they 0, that means the U8 here, okay. I go in looking into pin 1 and pin 19 U3. How many wire? Okay.
Oh, I see. You want to make sure there's only one wire to pin 1 and one wire to 19, and not
Yeah.
enough, and
Yeah.
not
Yeah, make sure no
no other wires.
other wire go
Yeah.
anywhere.
Okay, yeah.
And if you see you get only 2 wire go correctly, then what else? If you check the wire here, 1, 19, you measure pin 1, pin 19, they're supposed to be 0.
Are they 0 or are they 1? I'm asking you.
The 0. They're supposed to.
Okay, if they're 0, then
then the output pin number 18 will be equal pin number 2.
Right.
Pin 2 1, 18 have to be 1.
Mhm.
Okay, if they not 1, what I telling you, take pin 1, pin 19. If both is 0, what else we can do?
Replace the chip.
Replace the chip.
No, not yet.
Not yet.
Not yet.
Not yet.
Disconnect 18 and then
now.
measure.
Right now, I'm talking about in the lab,
Right.
not talking about the real world, the real circuit board. Okay, the thing is, on the real circuit board, you don't have any problem with the wiring.
Well, Mr. Pham, you already said, okay, we already checked the decoder and we had 0 and 0. The output was 0. We pulled the wire, we checked it, it was 0, and it went back up to 1 and 19, and it's still 0, but you still have a problem with pin 18.
Right.
So why wouldn't you change the chip?
No, you would disconnect the wire at 18, so you.
That-
Oh,
but-
yeah.
That's what correct.
Okay.
You remove the wire from pin 18
Oh, I see what you mean. And then check,
and
the,
measure.
and measure pin 18 and see if it's the logic that you want based on what coming out of 2. And if it's if it's the same, then maybe you got a wiring problem.
Okay, so if you remove that pin wire on pin 18, you measure it. You get 1. That means okay,
Mhm.
2 1, 18 1. So that will be telling you the wiring here, you get a problem.
Well, maybe where that dot is at, maybe you hook something up wrong.
For sure. Okay, the wire here.
Yeah, exactly. Maybe you hook something up wrong.
Okay, so that's why you can check the wiring. So in order to check the wiring, you're using the meter.
Right.
So you connect from here to here. They supposed to be ring, right? They connect.
Right. They supposed to ring.
And now you can go through here to guarantee they not ring anymore. Okay, they can ring in here. Only where they supposed to go.
Mhm. And they can ring at
Yeah.
YouTube.
If you try to run take it through around here, they ring. I know for sure you get a wrong wire. Otherwise, too much wire, you cannot see, where they connect you. That's why we have to use a meter to ring them out. You put the one side of the probe at the pin here, and now you can circle here. Guarantee not ring. They will be out here also. You can see they only ring at the pin only. And it will be ringing here. Okay, so that is the way how to check the wiring. You cannot see. In order to find out where the wire going wrong.
Hey, Mr. Pham, but actually we do utilize the concept of visual inspection. And I'm not saying that's all in all, but you want to visually look at your board and see if the wires are going where they should supposed to go.
Now, that is take a lot of time. That's what I'm telling you. Put the meter one side into pin 18 here. And another one, okay, and you can run around here, any wire here, any on the IC, not on the wire,
Right.
on the IC.
Mhm.
They not supposed to read, right?
Right.
And now on this IC, you can do the same. Okay, check on this one here, going down. They will be in here. The thing is they connected.
Mhm.
And if you run on this one, okay, they going down here. So on this IC, you keep run from the top here, going down. And they will be ring at pin number 3. That be okay.
Hey, Mr. Pam, so let me ask you this. So are you saying that those ICs that are immediately or somewhat connected to our problem, we check that IC from top to bottom by ringing it out, and then we know what pin that we want to hear ring, and if we hear any other pin ring, then we know something's wrong.
Right.
Okay.
That's why you can trade from that. Like you connect it to the pin number 1 of the U6, they ring. So you know that's wrong.
Yeah. Mhm.
I think the U6 pin 1 not supposed to connect to that. The thing
Only pin 3.
yeah, the thing is too many wire.
Right.
You cannot look into the wire
Right.
to find which wire going right or wrong.
So you're saying just check each IC from top to bottom and see
Right.
which one rings.
Right.
And you know what wire, what pin you're looking for. And if it's anything but that, then it's wrong.
Right. That's what in the company we do it that way.
Mhm.
I connect the one side, okay, of the probe in high side go here. And the low side, I just go to the pin of the IC, keep going down. If it's ring, that means there's some wrong. The thing is they're not supposed to connect you. And this IC, you do the same thing. You just run from here, and this point they will be ringing. Okay? And also this IC. Any pin on the IC, we just go up to down. If you ring, then we know some wire must be wrong. That is the way to check the wire. In the past, some students try to remove all the wire and rebuild it. That's not a technician job. Technician, you build only once. And now they're not working. We have to find out what the problem. That is your job. For a while you get along, then you can solve the problem quickly. Okay? Now, if you remove the wire from pin number 18 and you measure, they still be 0. Then you can say, okay, I need a new one, U3. The thing is when you want to get another IC, we asking you how you can get IC. Then you have to prove. You say, you measure pin 2 logic 1, measure pin 1 and 19 0, and we measure 18 not 1. And I remove the wire here. I measure, it still be 0. Okay, then I given you the new IC. Same thing at work. When you change that part, they will be asking you, how come? and you have to prove it to make sure that IC not working. So basically, troubleshooting you get the right input, but you not get the right output. Any question up to that point? Okay. So the first they write 5, they go here 5, they go here 5. Okay. And if you understand on the software basic, then you need to call the function to make sure you get 0 here. That function normally we call U3 enable. Okay, U3 enable. Now let's see test number 1.
A U3 enable hooked up to what on the decoder?
Okay, test number 1 here. Okay, so every test must be get it. Okay, no problem. That is the 1. You just fill in. Now you say send serial. So I put comment here. Okay, we don't need that. Okay, after that, you must be called the function enable U3. Then you can read. Okay, then you can read the data. It's just a formula. Okay, from here to here to here. That is my software. You cannot change anything here. That function will be helping you. They will be reading. Okay. They will be reading data from YouTube. Okay. And telling you get the right or wrong. Okay. So now, if you still get the wrong, then you can check a bit here to see which one is wrong. Normally, when they read it, they display, okay, what data wrong. I give it to you. Okay. Now I try to run. Okay. Okay, now when you run, they bring it out. Expect data, that means the data 0, 1, 0, 1, 0, 1, 0, 1. However, they read 0. So basically,
You're not hooked up to the circuit.
yeah, basically, normally they can get 0, 1, 0, 1, and 0, 1, 0, 0. Okay, then I looking into here, I know the first one will be wrong. Okay. The thing that we're reading here, we have no hardware. So that's why. Okay. When I get the hardware, I run, if the good board, they will be 0, 1, 0, 1, 0, 1, 0, 1. However, you can see only one bit different. They're telling you the last one fail. And that, if you looking, let's see. You're looking into the schematic. Okay, the last bit will be bit number D1, L2 D1, right here. You get a wrong here. So that's why they're supposed to be a 1, but I see the display look like they get 0. So I can check measure pin 18. If I get 18 is 0, then I check pin number 2 here. They will be a 1. They're telling you the problem with the U2. You get 1 here, you're supposed to get 1 here. Then I make sure L2 pin 1, pin 19 must be routed. And also make sure you get the power and route. Okay, so you get only 1 bit wrong. You get 1 here, but you not get 1 here. You can change the IC. The thing is the troubleshooting. More you do it, that will be helping you. Every time you see something wrong, you know right away how to troubleshoot to fix the problem. This is a job for technician, solving the problem. Okay, that is for the test number 1. And the test number 2 supposed to be okay. They just changing 55 to AA. And that will be the same row this way. Okay. And if something's going wrong, for example, pin 11 supposed to be a 1. Then you're looking right here. That pin supposed to be a 1. The thing is you already passed, okay, the first part, but did not this one. So you have to go back here to see 13 supposed to be a 1. So 1 in here, you're supposed to 1 in here. If you not get a 1 in here, then the IC is not working, or the wire. Get the extra wire here. This is easy to see. On this IC 1 pin 8, pin 13, you get only 1 wire.
In that case, you can do a visual inspection.
Yeah. If you get more than 1, guarantee you get extra wire or somewhere.
Yeah.
That easy when they get only single wire. Okay. And also, this pin get only 1 wire. They supposed to be a 1. And this supposed to be a 1. So now, if they not, you can remove the wire from pin 13. If you remove wire, you check it, you get a 1. Then this IC can get a problem. That's why every binary testing, they test for 1, then they must test for 0. If this pin they connect to 0 somewhere, you test the first one you pass, the thing is they supposed to be 0. However, when you test a second one, you want it to be a 1. If they connect to 0, they cannot get a 1. That is the law, the rules for testing the binary. Every wire must be tested for logic 1, then test for logic 0. So that's why every time you say, we write the program, we're using data 55 and the data AAA. Make sure on of the output will be tested for 0, 1, 0, 1, then 1, 0, 1, 0.
That's why you always have the U1, U2, U3, which is in a U shape. And you can test that 1 and 0 bit.
Yeah, that's what I'm saying. On of the wire here must be tested for 1, and later on you must be tested for 0. So that's why on the test program, testing, they will be using 55. Then they're using AA. The thing is, sometimes this pin connect to the route. If you test AA, you never see. The thing is that they will be 0. However, if you test 55, they will be failed. The thing is, they connect to 0, then no way you can get a 1. Or sometimes 2 pin, okay, pin 3, pin 4 tied together when they soldering the board. They tie together. Okay, so if you're not testing 55AA, then you never know. You test on 1. That means all the time they tie together. 1 here, that's okay. If they test on 0, then 0 this side, the other on 0. That be good working. However, some wrong. So that's why you test a 1 here, you have to test a 0 here. When they short together, then they must fail. Okay, and the question regarding into the test number 1 and test number 2, I believe in the past you already did it. No problem. And normally, when you do the test, you must be understand how the path of the signal going. They going here, they going down here, then they go to this one. So we can verify. However, also related into this guy right here, L number 8. So that's why in the PCOP, I say that number 1, PCOP will be L1, L2, L3, U8.
Because U8 affects number 3.
Right. Normally at the company, we don't care about the wiring. Cannot be wrong with the wiring. Only wrong with the part. Okay, so you can change U1. If they're not working, you can change U2. If not working, and you can change U3 and U8. Guarantee they must be working. But that is not the way technicians do it. Sooner or later, you get laid off. The thing is they get only U1, U2, U3, U8. You can own up them. Then what? Any board, they must be working. Okay, if you change everything. And also I can tell you one other thing you need to know. Okay, here. Okay, if you say pick up, equal L1, L2, L3, and L8. Okay, however, in the company, they will be say this one. Okay. Copy it. Okay. I mean remove and replay. Okay. I can put in here so you understand. Remove and replay. Okay. They're telling you remove and replay E1, E2, E3, E8. So when you given that into the assembler, assembler will be doing. They do it for you. First thing, they gen E1. Okay, a new one, give it back to you. And still fail. You give it to them, now they gen E2. And one at a time. They not gen all of them, okay? That is the rules. When you say E1, E2, E3, E4, E8, they gen E1 first, give it back to you. Then give gen E2, give it back to you. Okay? And U3, give it back to you. If you gen all of them, then they can talk to your supervisor. You get only 4 IC, you gen all of them. Then they must be right. That's not good. That is the way it happened in the company. Okay, that is the test number 1 and 2. So on the test number 1 and 2, okay, so you can say test number 1. Okay, you call this function, they do for you. Then you say enable U3. Okay, then they verify. After you're done on that, now you can test for a different data AA. This is the one I give it to you. You cannot change it. Then you say expect data will be AA. You call that function to send the data for you, and you must be enabled. Then verify. Okay? That is how we can get it done for that number 2. Okay? Do you have any question? I believe if you know something to do, you're able to get that 1 and 2 will be done. No problem. Okay? What else? Now, the next 3 and 4. Okay, let's see 3 and 4. What they testing 3 and 4? Okay, 3 and 4, that means they still sending 5, 5. 5, 5 here. Now, they go into the U6. U6 is 74, 374. 74, 374 just a D flip-flop. Okay, not a lot. That's a trigger, the trigger. In the past, you learn 74, 74. That means only one input, one output. However, most of in computer in the past, they're using 8-bit. So that's why they design flip-flop, the flip-flop for 8 input and 8 output. Only thing here, when you get the data here, you apply the clock, then the data at the input will be go inside here, not outside, inside here. In order to get to the outside, pin number 1 have to be set to 0.
Output enabled.
Output enabled. Then whatever input here will be go into here. Now, they go into here, and also they connect to U5. And U5 just a buffer. So you want that input go into the output here. Pin number 119 must be 0. Okay? Then they go to U2. They can verify. So on this test number 3, what they want to test, look what they want to check on this circuitry. For each test, you must be understand. On that test, they cover what I see.
U6.
You can see 5 and 6.
5 and 6 and what else?
U8
U8,
U8,
and
U4, maybe, I can't see it.
U4. No, nothing.
No,
to
no, no,
do.
no, not U4.
U9, isn't it?
Let's see.
U9, yeah, because it's
U9.
411.
09, okay. Inverter,
9.
okay. So that is what they cover. So when the test number 3 fail, then you don't worry about U1, U2, U3. The thing is they already passed. Now we have to deal U5 and U6. And what related? U9 something.
U9 and U8.
Only thing what you want, you make sure you get
Maybe.
dry input and you not get dry output. Something wrong with this guy. Okay? And if you get the data here, it's right. You want to make sure that data will be right here. The thing is the wire connection. They're supposed to be the same. If they not, guarantee you get a wrong wire somehow. And if you get the input here, it's right, then you can make sure output will be wrong. The thing is that failed. So must be wrong somehow in here. Okay? And make sure pin 1 and 19 must be 0. Okay? Then you can check the output here. If the input is right and output here some wrong, okay, then you can change the U5. Okay? So,
Hey, Mr. Pham, wasn't part of that when we were talking about the peak offs for this particular test, we said 5, 6, 8, 9, and would 721 play a part? Because pin 1 output enable go to U721.
okay, let's say go if 721. PD pin 4. Okay?
Mm,
That means you take U7 pin 21, they're supposed to be 0.
Well, I'm looking at U6 pin 1
Yeah, they connect the same.
go to 721.
Right. That means they can say right here, PD pin 04.
Mm,
That means they get a wire going from pin 1 to pin 21.
right.
So pin PD pin 040, then they must be 0 here.
Mhm. So would U721 qualify as a peak off of test 3?
No, it wouldn't,
Okay,
Now,
Yeah,
the wiring.
because
That's the wiring.
PDO4 is going to U61 and
Yeah.
also U721, but
Right.
we're not looking at U7 yet.
Right.
right, okay.
Perfect.
Okay, good. Thanks, Mike.
Yeah, that's the thing is, you guys, sometimes you have to tell me, okay, what you think, okay? The thing is, if I try to think the people cannot follow it, cannot do anything, I'm not really happy. And you can stay in the program forever.
Okay, I'll be
I
here
don't care.
forever.
I don't care you want it or not, but that is the way the program running. This is real job. Teaching to the real thing happen at your work. Your job at work, that's what you do the same. You test the circuit board, they fail. How can you fix that board? Nowhere they can teach you like we doing in this program.
This is real world troubleshooting.
Right, that's a real, really the real one. So we get the test number 1 to test number 12. I saw some students, they get around a half. That's okay. However, on the form, then you have to start over.
And Mr. Pham, I wanted to ask a question.
Yeah,
and maybe you, Lou, can jump in and answer this too. When Mr. Pham was checking his DLAB 12, did you say you only wanted us to do the first 6 tests?
I only did 6 because that's what we understand, what we have done.
Or
But,
should we try to do the whole thing?
yeah, because at the step manual DAC circuit test, it say 10 tests. So I'm not too sure what that is. So that's why I stopped there.
Okay, on that one here, you see on the last one, I send it to you on the A converter, right?
Right.
Don't do anything on that one.
Don't work on this one yet?
Yeah, don't do anything.
Okay,
Do on number 12.
all right, do number 12.
Now, the next time, I can tell you,
You want us to do this one right here, correct?
right. Now, I can tell you quickly. Okay, this is the memory. We're testing, okay, data 55AA. We're testing for data we're loading to 43 location and read it back ADC data, right? That's what in the past we already did it. Now, the next one, you sending the data U10, 55, AA, and FF. That means that data will be stored inside memory. When you write that location, the data 55 go into here. And that will be go to 11. That go to the second part right here. Okay.
Mr. Pham, did you just say when you write or when you read?
Okay, now I'm telling you, on your store data to the memory, okay, you can store data 55 at one location, data AA at another location, and the data FF. That means you get 3 extra locations for those data. So now if you want the data go here 55, then you have to read from memory.
Okay.
At that location. They going out here. They go into input here. And you need to enable U10.
Okay.
Okay. So they ready in here. Okay, now they will be ready in here.
Right.
And after this circuitry coming out here, they will be around 3 volts or something. Okay? And that 3 volt here will be go into right this point right here.
Right.
And now on this one, they using R4, R5 voltage divider. So they can get a half 1.35 volt here, divided by 2. Okay, and they add a capacitor here. That's what they call a sample and hold. That means the 1.5 volt here, they need a capacitor to make sure they will be stable. Okay, 1.5. And then you go to the follower. You get a 1.5 here. Output, you get 1.5. Okay. And now 1.5 go to this IC A to D converter. They converting back to a binary they will be supposed to be 0.5050505. However, this is the analog. They get the tolerance. So that one cannot be 0.5050505. Okay? Whatever they come out, you need enable U16. So this data going back into
Let's see.
right, perfect. Going back into port C. Okay. However, when they read the data here, you cannot expect 0.5050505. And the thing is they get the tolerance. Okay. So now I show you the last one here. ADC. I'm looking for ADC test. Okay, you see that memory ADC. So this is just loading the data to the memory. Okay, and this one, they write the memory address, expect data, ADC data. Okay, expect data, ADC data. So that is just write the memory, not that on that ADC right here. For that ADC, first thing, they write the data, okay, for AA, and they expect they supposed to be 6.64 volt. How come? Now, you can see ADC data here. Okay, this is a binary. Okay, and if you get the data, okay, let's see, 0.8. On this one, they not send that one, but that's okay. For example,
55 is on the next page.
yeah,
It's number 42.
right. I don't get that, but I just telling you, when you send the data here, that means 0.899. They converting this one to the decimal 153. Okay, so now the deck current out, they will be calculated. You get 1.19. So the value you want in the voltage, they will be 5.9. So you know, we already know how to calculate that one. You can take 2 milliamp times 153 divide 256. That's what you get, that value. And if you get the current here, you multiply by 5K, you get that voltage. So for the data 0.899, you apply, you send it out, you cannot get the output to be 0.899. The thing in the analog input, they get tolerant. So that's why you have to get your voltage, okay? So if you're looking into the program here, it says tolerant. That means you want calculation to come up with 6.64. However, they are analog, so they get tolerant. unit will be a VDC, and that peak off we don't care. Okay, this is the thing they tell you to adjust the port. Now,
And Mr. Pham, that 6.64 is the voltage that you get at test point 1.
yeah, 0 point. Yeah, we said you can see that the voltage you supposed to get right here.
Okay. And then when you go to the next op amp, you should get half of that, correct?
Right, you divide by half.
Right.
Okay, the thing is why we have to do that. Basically, this IC, they can handle up to 5 volt. Right here,
Mhm.
only 5,
Mhm.
0 to 5. Okay, so you cannot get a 6 volt in here. They're not working. So that's why you have to divide it down. Okay, however, when you divide it, when they come in binary here, you have to bring it up again. That is the way how the board can handle. For example, coming in 100 volt and the IC inside AD converter, they cannot up to that voltage. You see that? They cannot go up to 100 volt. This IC only handle up to 10 volt, for example. So what can you do? Before you connect 100 volt here into here, they have to get a lot of voltage divider. Keep divide down. You have to divide by 10. 100 divided by 10.
So that'd
means
be 50 and 50.
you get 10 volt, right? If you get 100, you divide by 10. That means the voltage will be 10 volt.
Right.
So when they go here, they work okay. However, when coming out, you have to memorize. You already divide by 10. Then they coming out, you have to multiply by 10. That's the way how the tester or the test system in the company we do it. When the voltage too big, you cannot measure. Then you have to divide it out. And you divide depending on how many times. Divide by 2. Then when you come out here, you have to multiply by 2. Okay? So up to that point, I will be stopping. Okay? Anything else? Any question? I can help you.
So Mr. Pham, on the test requirement, you said that after number 7 is manual DAC circuit test, and there are 10 tests. What are the 10 tests?
Oh, on manual only, that means I testing only DA converter, not A to D. So that's why that a manual mean when you're writing AA into A, D to A, they will be telling you connect the meter to that point 1. They supposed to display 6.6 somehow.
Right. So
Then,
we have to write the program for that.
no,
and
not
then-
yet. When we get into the, I will be given to you that program for the park manual.
Oh, okay, so we just
Right.
ignore that part for now.
Yeah, so
Okay.
that one, when you run that program, they pass that main on of the park up to D to A converter, no problem.
Right, okay,
So when you run the second one and it failed, they will be in the AD converter.
right.
Okay, that's very good.
All right, thank you.
Yeah, you are welcome. Okay, so good night, everyone.
Okay, thank you, Mr. Pham. Good night.
Good night.